Secants and tangent to a circles. It is the most important chapter in your textbook. That is secants and tangent to a circles. Circles 1 that you have learnt in 9th class. Now circles 2. Entire circles we divided into two parts. One is that circle term language of circles, and second one is arc properties and chord properties we discussed. Now we are discussing tangent properties. Before that, I am going to teach the total language of circles, terms of circle. Some terms are there. The terms you must know it, then only you are able to do the circles well. So what are the terms in it? First, what is meant by circle? A collection of infinitely many points which are equidistant from a fixed point in a plane is called circle. Once again, listen carefully. This terminology you must get it well. Once you got this terminology well, remaining definitely you can think it well, and it gives you good logical skills and analytical skills. Deductive thinking is nothing but a scientific thinking. Such kind of thinking you will get it. So that's why everyone listen carefully. Okay. Definition of circle. A collection of infinitely many points which are equidistant from a fixed point in a plane is called circle. So fixed point, I am taking one fixed point. You take some distance. Suppose 5 units distance you take it. Here you take one point. Like that infinitely many points you take it. Each and every point is 5 units distance from this fixed point. So like that it is the collection of infinitely many points which are equidistant from a fixed point is called circle. In a plane is called circle. Here you must use the term plane. So circle is a plane figure. If suppose if I am taking point here, this is a fixed point, no, and he is taking 5 centimeters distance from this point in a space. So it is also possible. These are the collection of infinitely many points which are equidistant from a fixed point in a plane is called circle. That point must be in the plane. Point plane lo lekunda space lo kuda teeskunteno what it forms? Sphere. Because sphere means a collection of infinitely many points which are equidistant from a fixed point in a space. In a space, that is a 3-dimensional figure. It is the 2-dimensional figure. That is the solid figure. This is the plane figure. That's why you must use it plane. Okay. So this fixed point O is called center of the circle. Now here I am drawing infinitely many points. No, just let it be one point. You take it as a. So you take any point on the circle. Any point on the circle you take it. That we called as a radius. This fixed distance is called radius. It is the fixed point. Fixed point is called center of the circle, and fixed distance is called radius of the circle. So here radius definition, it is a line segment. It is a line segment join from center of the circle to any point on the circle is called radius. Here OA is called radius. This radius is denoted by small r. This radius is denoted by small r. Now my question is, how many radii can be drawn to a circle? Infinitely many radii can be drawn because infinitely many points are there on a circle. So that's why you take any line segment from a center to point on the circle, that indicates radius only. So how many radii can be drawn? Infinitely many radii can be drawn. Fantastic. So we discussed center and radius. Center and radius. Now just you take a circle, otherwise here we took circle. No, you take any 2 points on the circle. Any 2 points on the circle you take it, join them, one line segment forms. That line segment is called chord. CHORD, chord. That is called chord. These are the terms of a circle. What is the third term? Chord. What is meant by chord? It is a line segment joining any 2 points on the circle is called chord. How many chords can be drawn to a circle? So infinitely many chords you can be drawn. Infinitely many chords. Because this circle has infinitely many points. No, you take any 2 points on the circle and join it, and definitely you get the chord. This is called chord of a circle. Fantastic. So you draw infinitely many chords. Just one chord I am drawing. These are the infinitely many chords. No, one chord is definitely passes through the center of the circle. Then that chord is called diameter. So how many diameters can be drawn to the circle? Infinitely many diameters can be drawn, because any 2 points you can take it on the circle, and that chord is passes through the center of the circle. That indicates chord. So these are all chords only. So infinitely many chords can be drawn. Now observe here, the chord which is passes through the center of the circle is called diameter. So like that, infinitely many diameters can be drawn. Then just you observe something. That is just a common sense. And that observation also a self-observation. If chord is moves towards the center, then the length of the chord is increased. Fantastic. Now observe here, the chord which moves away from the center, the length of the chord is decreased. Now, if I am asking you one question to you, that is, once chord is nearer the center, one chord is farther the center, then which chord is bigger chord? The chord which is nearer the center is called bigger chord. The chord which is farther the center is a smaller chord than it. Fantastic. Here, see, chord which is passes through the center is called diameter, no, but the length which is any point on the circle to center is called radius, no. So what is the relation between diameter and radius? Diameter is equal to 2 times of the radius. Fantastic. One more term we are discussing now, that is secant line. What is it? Secant line. Just you take a one line which intersect the circle in 2 different points, then that line is called secant line. We are discussing the terms of a circle. In a terms of a circle, we discussed first definition of a circle, center of the circle, radius of the circle, chord of a circle, secant line of a circle. How many secant lines can be drawn to the circle? Infinitely many lines can be drawn. So the secant line which touch the circle at only one point, then that secant line is called tangent. That is called tangent. Just some properties we will discuss on tangents. Before that, it is a circle. I am giving you one point in interior that you have known in a previous class. How to determine the point which is in interior of the circle, it is the center, or exterior of the circle, or on the circle. How to determine the given point, whether it is interior or exterior or on the circle, that we can determine with the help of radius. Observe here, radius, this is the radius, no? Now join OA, and the distance from O to A is smaller than radius, then definitely that point A is interior of the circle. The distance from O to C is on the circle now. C is on the circle. The distance from center to point on the circle, OC is equal to R. Then definitely that C point lie on the circle. If the distance from point to B is greater than R, then definitely that point B definitely exterior of the circle. Now my task is, how many tangents can be drawn through point A, through point C, through point B? That is my question. How many tangents can be drawn through internal point of a circle, point on the circle, and point which is exterior of the circle? My question is, how many tangents can be drawn through point A? Point A means which is in interior. How many tangents can be drawn through point C? How many tangents can be drawn through point B? First, if I am asking you any question, first you must keep in your mind the definition of that. What I am asking you? tangents. What is meant by tangent? The line which touch the circle at only one point, then that is called tangent. Through A you draw the lines. Is it possible to touch the circle into only one point? Is it possible this line do not touch at only one point? Infinitely many lines can be drawn through point A, but all are definitely cut at 2 points, so that's why these are the not a tangents. So the number of tangents can be drawn. The point which is in interior of the circle is 0. No tangent can be drawn through a internal point. Now with point C you take it. It is the point on the circle. Only one tangent can be drawn. Yes, it is also correct. Only one tangent can be drawn through the point which is on the circle. Which is on the circle, one tangent can be drawn. External point you take it. In external point like that infinitely many lines you can be drawn. Among these lines, how many tangents can be drawn? Definitely 2 tangents can be drawn. One tangent is possible this side, one more tangent is possible this side. So that's why, see, it is not an endpoint, can extend like this, no problem. When that line is passes through that point or not, you observe. So from an external point, the number of tangents can be drawn to the circle is only 2 tangents can be drawn through an external point. Good, fantastic. Next, what is meant by arc? See, the part of a circle is called arc. See, here AB is one part and BA is the another part. AB is called minor arc because its length is less. So that's why it is a minor arc. From B to A, that is called major arc. This is the minor arc, this is the major arc. How many arcs can be drawn to the circle? Infinitely many. Just you take a one bangle and break it, you will get the parts, no? That parts are called arc. Okay. Next, what is meant by sector? Sector is the circular region bounded by the 2 radii and corresponding arc. It is a part of region, a portion of region, a portion of circular region which is enclosed by the 2 radii and corresponding arc. Here I am taking suppose P. OAPB is a minor sector. It is a minor sector. OAQB is the major sector. What is meant by sector? It is the portion of circular region bounded by 2 radii and its corresponding arc. Next term is segment of a circle. Here observe the circle and AB is the chord. Portion of circular region bounded by the chord and its corresponding arc is called segment of the circle. So this is the one region and this is the other region. Now observe this region APB is the minor segment and AQB is the major segment. Okay, observe here, any angle in a minor segment is obtuse. The angle in major segment is acute. Okay, in a major segment acute angle forms, in minor segment obtuse angle forms. What is meant by segment of the circle? It is the portion of circular region bounded by the chord and its corresponding arc.